Right, good to go.
All right. Welcome, everybody. We are excited to have you here on the second of the soil seminar series this spring semester of 2022. And today we are going to hear from Dr. Jim Jordahl. Thank you so much for sharing this time with us. And as it goes, we are going to first acknowledge the land on which ISU campus sits. And the acknowledgement goes, Iowa State University aspires to be the best land-grant university at creating a welcoming and inclusive environment where diverse individuals can succeed and thrive. As a land-grant institution, we are committed to the caretaking of this land and would like to begin this event by acknowledging those who have previously taken care of the land on which we gather. Before this site became Iowa State University, it was the ancestral lands and territory of the Bakoje or the Iowa Nation. The United States obtained this land from the Meskwaki and Sauk nations in the Treaty of 1842. We wish to recognize our obligations to this land and to the people who took care of it, as well as the 17,000 native people who live in Iowa today. So today we are going to listen to Dr. Jim Jordahl. Jim is a project analyst on Dr. Lisa Moore's team at the ISU Bioeconomy Institute. He received his MSc in soil management from the agronomy department, and his advisor was Dr. Doug Curran, and he earned his PhD in environmental science from the University of Iowa. Jim had a long career with a large consulting engineering firm and was most recently with the Iowa Agriculture Water Alliance. In addition to working on multiple carbon and greenhouse gas projects, Jim has done extensive work across the United States and abroad on the design and management of soil plant systems to achieve desirable environmental outcomes, especially in highly disturbed or contaminated environments. Today, Dr. Jim will talk about the science of carbon credits, and it is at this juncture that I welcome Dr. Jim to take the floor. Thank you so much, Dr. Jim.
A kind introduction, and thank you for the opportunity to share a bit about our recent work. Today I'm going to talk a bit about the science of carbon credits, especially in the context of carbon markets. And going here, and thank you for Marshall for coordinating this and making this possible. And now it's not. Uh-oh.
Sometimes it's just a matter of touching the, I'll try it.
There we go.
There we go.
There's been a lot of things in the news the past few years relating to carbon and carbon markets. A couple of years ago, Iowa Soybean Association launched the Soil and Water Outcomes Fund, water quality and carbon credits. Lots and lots in the news, lots of controversy about the pipelines and CO2 storage in deep underground. Many different partners or private entities have carbon programs. Corteva has released a program. Land O'Lakes Truterra has a program, and other things happening in the livestock sector. 3 large dairies in Northwest Iowa working together to provide feedstock for a renewable natural gas project. And so lots of things happening. But in general, we're seeing that there are carbon buyers willing to pay for reductions in greenhouse gas emissions and for removal of carbon or sequestration of carbon dioxide. There's kind of a parallel desire to develop policies that can support that in terms of market development here in Iowa. So the most proximate driver for the work that we've been doing this fall was an executive order from Governor Kim Reynolds positioning that Iowa would be the leading state for creating carbon value through agricultural stewardship and energy generation. So that was back in June, that executive order came out, and that led to the formation of a carbon sequestration task force. There were a couple of members from Iowa State that were on that task force. And as they were forming, they realized that they had gaps in what they knew. in order to formulate policy. And so they came to Iowa State and said, please provide a carbon assessment, background science for us in order to formulate these policies. And Iowa State had been thinking about doing a carbon study and had taken a couple of years. But we had like 2.5 months when this started out to do this as much as close as we could to the same thing. So it was very much a rush project. But by December 7th, the task force presented its policy recommendations. As far as the overall report, it's not yet out, but this is what the cover is going to look like. It's called Carbon Science for Carbon Markets, Emerging Opportunities for Iowa. And this work represents the contributions of some 51 scientists across campus in 13 departments, 4 colleges, 4 institutes. And so this is a lot of coordination and a lot of work happening in a short amount of time. And Dr. Schulte-Moore and I were the co-editors in pulling this work together. And so I'm one person representing the work of a lot of different people. And so I want to acknowledge that. And my expertise is not complete on all of these areas by any stretch. The work is not out quite yet. We hope to get permission from the Iowa Economic Development to release that, hopefully any day or within a week or so. But it's not yet released. It's complete, but it's not yet released. As far as the why of the science assessment, again, both farmers and those investing in carbon markets need to know that the practices that might be used are actually storing carbon and that the measurements of the practices and the carbon are accurate. And so some of the questions that were posed by the task force to us were, what is the effectiveness of a practice given no-till or cover crops or perennials and technologies? How effective are they? And what are the gaps in what we know? What do we know and not know? And if we have gaps, how can we go about filling those gaps in order to support carbon markets? And on the market focus side, how do we improve the credibility and therefore the market value? A commodity has to have credibility in order to have greater value. And so that's kind of part of the focus of what we were doing throughout is thinking about that issue of credibility. And part of the thesis we kind of developed from the introductory materials was that Iowa has an advantage in these carbon markets. And part of that is data. We have some of the best soils data in the world. Dr. Bradley Miller pulled this figure together for us on our carbon stocks in the profile as measured by molic colors in the soil. Iowa has some of the highest productivity in the world as far as the Corn Belt as measured by gross primary production. This is the hot spot for capturing energy from the sun and through photosynthesis, locking up carbon dioxide as measured by sun-induced chlorophyll fluorescence. And from the original paper, you can kind of see the Midwest and Iowa in particular as being the hot spot for that photosynthetic potential to grab and productively use carbon. And kind of bringing those advantages together, we have the favorable climate and soils, we have the extensive scale and high productivity of Iowa ag, we have the capacity to store a lot of additional carbon. We've lost about half of what we had originally in 1850, and so that implies a significant capacity to store more. We have the research capacity, public and private. We are a proven center for ag innovation, and again, we're rich in a lot of the data that we need. So as far as the overall report, what I'm going to cover today, I'm going to touch a bit on the carbon markets question. Dr. Plastina is going to be here in a couple of weeks, go into much greater detail on that. Some of the measuring and reporting and verification questions that are associated with the carbon markets, cropping systems and land management, and a bit on some of the livestock practices as well. But I'm not going to have time to get to some of the other material that suggest you look forward to in the report on the engineering technologies. This is kind of heavily biofuel type based, some novel fuels that might be possible. The rate of practice adoption of the relevant practices to sequester carbon, planning tools, Emily Zimmerman's adaptation of the ACPF tool and bringing in carbon, and some process-based models and how we look at this. And then finally, the life cycle assessment, which is important to how we think about the whole supply chain impacts of these practices. So jumping into this material, again, led by Dr. Plastina, thinking about the supply and demand of credits and how these markets work. What's been in place for some time is the compliance market. There's some regulatory driver in California. It's a low carbon fuel standard. In the Northeast US, it's the Regional Greenhouse Gas Initiative, or RGGI, creating some regulatory driver for folks. And that leads to a carbon offset opportunity. What can we do to mitigate those emissions? It might be agricultural methane, there's provisions for rice production in California, adjustments to management. Forestry is especially important. That's where a lot of the credits or offsets thus far have gone, is into the forestry sector, and landfill gas mitigation as well. All these are tracked through various registries and leading to tradable offsets. But most of what our focus has been is on the voluntary side, the voluntary market. And rather than regulatory, it's a marketplace driver. There's various corporations have made these net zero pledges of net zero emissions by 2050, for example, and they want to meet those sustainability pledges. And the intent is to try and meet that through a credit rather than an offset. It might be the agronomic practices like cover crops or no-till, avoided land use change, restoration, those kinds of things. But the real active player in this scheme really are these project developers, the Corteva and the Soil and Water Outcomes Fund and others, working with various registries to pilot protocols, trying to figure out a way to make this work on the voluntary side. And rather than selling credits thus far, they're operating with venture capital and some funding from what are called the angel investors, high net worth folks, with the hope of getting to an approved protocol and ultimately tradable credits. Indigo Ag is one of the players in this space, and they're kind of the first one to the finish line getting to an approved protocol. Some of the highlights from this chapter, that these voluntary markets can be viable, but many private firms are establishing a presence. But there's a lack of uniform standards and guidance that's kind of confusing to farmers as well as potential investors. And that's kind of a hindrance to market development while there's all this multiple things going on. There's evidence that farmers are definitely interested in this market, but there's quite a bit of uncertainty over when and how to engage. And some of the challenges to making this marketplace more robust are kind of well known to the economists, the factors that limit a market. And a lot of them tend to hinge on what the credibility of these credits are, how good is that carbon credit, and also how costly is it to get to a certification for that credit. In general, the currency of these markets is the metric ton of carbon dioxide equivalent, or CO2e. And we can get a credit, so to speak, from an avoided emission, a greenhouse gas that isn't emitted, or a removal, generally a removal of carbon dioxide, and locking that up somewhere. A number of ways to get there through conserving energy, materials, alternate energy sources, carbon farming, quote unquote, biochar, and various elements that we'll talk about in a bit. That's the general thing that we're talking about. This complicated figure, I'll walk you through it a bit. This is a number of these in Alejandro's material, but this is the general flow of carbon offset and credit markets. The farmers actually implementing the practices. There's project developers kind of coordinating the whole thing, possibly third-party verifiers making sure that this has happened or giving assurance that things are on the up and up and have happened. And there's registries that develop very specific protocols on what needs to be done to have a saleable credit. And then the ultimate user here on this side. So the flows of information and material, the method of how this is going to be tracked, the protocol of what's going to be done to make a viable credit is issued by these registries, and that flows down through the project developers and ultimately to the farmer implementing the practice. It influences the farmers anyway. The data from the project flows up from the farmer's field through the project developer. And some of that may flow directly to the registry, and some may go through a verifier, again, making sure that it's solid. And that's the data flow. As far as show me the money, where are the dollars? The dollars ultimately are from those obtaining the credits, and that's going to fund ultimately the project developers, as well as providing funding to the verifiers and ultimately payments to the farmers. That whole integrated process is kind of common to all of these different programs. But there's variations among this. This is the schematic for the Ecosystem Services Market Consortium, ECMC. There's Soil and Water Outcomes Fund, there's Indigo Ag, there's NORI, there's Corteva. All these are a little bit different. Ogoros, and then CIBO, and Gradable, and Bayer Carbon. And there'll be an exam at the end on all of these. But anyway, a lot of complexity, and eventually the dust is going to settle on all this, but it's still pretty complicated at the moment. In terms of farmer perceptions, some of J. Arbuckle's data, given a statement, programs or markets for carbon capture should be developed to help farmers earn money from adopting practices that capture carbon. In general, majority tend to agree with that general concept, but there's a high level of uncertainty as well on what this means going forward. And individually, would I participate in that kind of a carbon program to capture carbon through soil health practices? Very similar results. It's, well, maybe, but a lot of uncertainty going forward, and understandably so. One chapter we have in the report is on this question of measuring, reporting, and verification. Very important element to these markets functioning. And I led this particular chapter. Some of the conclusions from this overall is this space of measuring and verification, and the credibility and cost are especially crucial in here. And it's a very complex, rapidly changing space with a great need for standardization and getting more efficient and credible ways to gather data. We need lower cost, credible tools, especially for soil carbon. And I'll dig a little deeper into that in a moment. That's a big one. Methane is maybe a little bit better established kind of through the compliance market, and we can produce renewable natural gas, but that's kind of a process that's a bit better understood. We can measure for methane leaks and capture and market the gas. A couple of pieces of the puzzle on the monitoring, reporting, verification is the farm level practice data. Was a cover crop planted? Was no-till done? Were various practices implemented? That's comparatively cheap and easy to collect, and better tools are kind of coming all the time to help track that. But the environmental measurement, especially soil carbon, is somewhat less standardized and can be kind of costly and slow the way we are set up currently. But all that has to feed back into these market processes. So things that we're hoping to try and accomplish, or goals anyway, are to enhance and standardize the sampling, remote sensing tools and measuring tools, ways to measure the practices, hopefully get data to drive some more accurate models and calculators for carbon, hopefully to increase that credibility and cost effectiveness of the process that feeds into how these markets work, and hopefully ultimately to create value both to the credit user and back to the farm, back to Iowa in some way. Measuring soil carbon, I mentioned, is a significant part of what we're talking about here. The protocols are generally calling for dry combustion, total combustion processes for measuring carbon. That they accept that, but that's a pretty expensive tool compared to what farmers typically do with their co-op, is a loss on ignition, muffle furnace type method. But the markets are generally not accepting that. There's a lot of variation in exactly how that's done, and needs maybe some local calibration by watershed or by MLRA to have some confidence in that data. But there's maybe some hope that we've discussed in the chapter about maybe being able to use some of this data with some improvement to kind of leverage some of the more expensive dry combustion data. Infrared sensors, I believe at least one of the protocols is starting to look at infrared sensor data as being acceptable. Oops, what happened there? And essentially all of the protocols involve some kind of a model. But typically they're requiring some sampling as well. When we discuss in the report and as a team quite a bit is we need better models and better data as we go forward. Kind of rushing through. Are there any questions before I kind of keep rolling here?
Cross connection, are there any
I have a question, Jim. So it strikes me that the uncertainty in the spatial variation is far greater than the uncertainty from loss on it from methods. So like, does that ever come up?
I'm going to talk about some of the spatial questions in a second, but yes, that's also very important. Absolutely.
For those that are asking questions here, if you could repeat the question before you answer it so they can hear online, that would be fabulous.
Okay, the question was, isn't the spatial variability, the sampling variability greater than the analytical variability? And definitely is important, yes. Get my question?
So the registries, I'm confused about that. Is that going to be in the public domain or is that going to be owned by the company?
That's a good question. On I believe on the compliance market side, that is more of an open market situation, but on the voluntary side, it's somewhat more driven by the companies and their desire to meet their sustainability commitments. And so whether that will be openly traded, I don't really know. So other key questions: where do we sample? How many samples? How deep? And measuring bulk density is another non-trivial question. Some of the challenges of measuring organic carbon, how much is there? What are the rates of change? How does cropping management environment influence that? In addition to measuring it, we want to model it. We need something that's relatively fast, inexpensive, and as accurate and precise as possible, and proven at farm scale. This is big scale stuff that's happening. And so we need the concentration, the bulk density, and volume to get at the stock in space. And that includes, of course, an element of depth. Our data to date is pretty limited on depth, generally in the surface foot or less. We need more data with depth. We need to consider hill slope position, things that Bradley Miller's input want to include that. And we need to understand those changes through time. And we may need to also think about where are we in this overall process of accumulation of organic carbon over time, and those curves look different depending on where we start. Comments on that, trying to bring a lot of things into one slide. Remote sensing, we deal with that to some degree. Brian Gelder's information, we've got pretty good data now on measuring crop residue, but things like soil carbon and some of the other elements of the picture are a little bit more challenging for us on our remote sensing side. Cropping systems and land management, I've already touched on that a bit in terms of the measuring and reporting. Michael Thompson led this section. Crop production and management of the soil can increase or decrease emissions kind of depending on what's going on and how practices are interacting. As far as increasing soil carbon, we can have a pretty good handle on what practices in general will do that, reducing the tillage, adding residue, winter cover crops and rotations, extended rotations and perennial crops can help. But improved management of nitrous oxide emissions from cropland will have a greater impact on CO2e emissions than land management that focus solely on storing carbon. We cannot ignore the nitrous oxide part of the picture. Was a very strong conclusion from the report. Borrowing a slide from Marshall, we accumulated our organic carbon over some 10,000 years or more, and we started cultivating that. Loss especially pronounced in the early part of the 20th century. We're off to the present day, and now we're looking at no-till and cover crops and other practices to start rebuilding that organic matter. With some question of exactly what curve are we on and what is possible. This is kind of a summary graphic in the report, too small to read at this scale, but in general, trying to look at the range of different agronomic practices from artificial drainage through fertilization, through perennial crops. What is the likely increase in organic carbon or decrease in emissions of nitrous oxide and methane, or a more negative result, a decrease in organic carbon or increase in emission of the more potent greenhouse gases? And the tilde and dots represent relatively unclear or unknown impacts by practice. Kind of zooming in a bit, question of artificial drainage. Standard practices likely to lead to decreases in soil organic carbon, but as a plus, generally reduced emissions of nitrous oxide. Nitrogen fertilization is going to be especially important, kind of focusing on optimizing rate and timing is being beneficial to organic carbon as well as nitrous oxide emissions. The question of nitrous oxide, again, is very, very important. Very large component of overall CO2e emissions from US agriculture, over half. Some 94% of the nitrous oxide emissions from Iowa are from agriculture, according to DNR data. And the global warming potential is nearly 300 times that the impact of CO2 in terms of the forcing function, according to the assessment report number 5. And again, the nitrous oxide emissions could be double that of what we might get through a combination of something like no-till and cover crops. So nitrous oxide management is going to be crucial. They are a strong nonlinear function of rate. Small changes make a big difference, but getting to what is the right end rate is still a vexing question. So kind of summarizing the overall research needs, additional work on nitrogen rate and nitrous oxide response to rate, impact of drainage system design and management. Mike's doing some great work near Ames here, kind of answering some of those questions. The spatial variability of the carbon dynamics across landscapes, and you're involved in this area as well. Understanding what's going on at depth, going to be extremely important. And what happens when we combine practices? What data we have tends to be practice by practice, and what synergies we have, adding them together is somewhat unknown. And the carbon and greenhouse gas impacts of cover crops and perennial grasslands, we really don't know enough there yet. Part of the answer is going to be additional meta-analysis, but needing some long-term field experiments as well. Just briefly on the livestock side, led this work. This is a farm in eastern Iowa with a couple of anaerobic digesters. The carbon and greenhouse dynamics of Iowa animal agriculture is pretty different from national US averages because of the swine population. It's unusually large compared to national averages. Livestock emissions are kind of in two general categories. That of enteric emissions, essentially burps of methane, particularly from ruminants, but monogastrics like us pass some methane as well out the other end. But in general, mitigation for that is via some type of combination of diet and feed additives. In ruminants, it's kind of what's mainly being looked at to mitigate the enteric side. The manure emissions, we're looking at both methane and nitrous oxide emissions, and they're heavily influenced by how we manage the manure and going forward. Anaerobic digesters emerging potentially as an option to help manage methane emissions in particular, but a lot of questions yet to answer there and to adapt it to Iowa scale agriculture, especially on the swine side. As far as Iowa being different on a US basis, the dairy sector is over half of manure methane emissions, but in Iowa, it's like 87% on the swine side. As far as mitigating those enteric emissions, it's primarily nutritional, dry matter, feed additives. Farmers already feed additives like monensin that improve feed efficiency and reduce the enteric emissions. Some research has been done on seaweed. It's pretty effective at reducing emissions, but the practicality of shipping a lot of seaweed to Iowa is probably pretty questionable. There's other things that are looked at and reported in the chapter of vaccines and genetic manipulation, rotational grazing, and lots of factors, but a lot of question marks still on those areas. On the manure side, the liquid systems are where the methane is primarily coming from. On the solid side, that's more where the nitrous oxide is coming from. A range of practices can potentially mitigate that, in addition to the digestion, composting, separating liquids and solids, acidification, various additives potentially. But the efficacy of doing any of these elements depends a lot on the type of storage, how full the tank is, the composition of the manure, which can vary farm to farm, raising the same livestock, the weather, how it's land applied. So there's a lot of factors involved there. Getting to the end here, as far as our overall conclusions and path forward on this, again, this was a driving force behind the study, was this kind of vision and trying to provide the science around doing that. We see there's a range of options for carbon removal and emission reductions. Toward the more ecological side, these things tend to be less costly, might be somewhat more challenging to measure, but opportunity to innovate there. But there's a vulnerability to reversal, which impacts the value in the marketplace. We can go all the way to the other side, more heavily engineered solutions, maybe more costly, especially in terms of capital investment, but things are easier to measure and maybe somewhat less vulnerable to reversal. But we think it's kind of an all of the above solution in the long run, most likely. This is a figure from chapter 4 in the report. We have a baseline condition, very roughly of relatively neutral in terms of ag on CO2 emissions, maybe some net sequestration, but a lot of emissions of methane and nitrous oxide, livestock and cropping in particular. But a future decreased emissions scenario, getting to at some point, is increased carbon storage in the soil, potentially aquifer materials and other approaches, as well as decreased emissions of methane and nitrous oxide. So it's not an either or, it's definitely a both. The credibility of carbon credits are a precondition for the markets to function. We're trying to create conditions for that. We know a lot that can be used to support these practices and the markets in Iowa, but there's a bunch of key gaps that remain. But we think there's some exciting opportunities for farmers, government, industry, and academia to collaborate to improve the credibility and cost effectiveness of the programs and fully leverage what we're seeing as the Iowa advantage, photosynthetic capacity, and so forth. And some other elements of the path forward for ISU specifically, there's a number of pre-existing ISU programs that are extremely relevant and that need to continue to provide information to us. What will happen on state and federal policy is important, but unknown. What industry will do on sustainability measures and supply chain, I don't know. What international agreements will happen, we don't know. So uncertainties there. But we think we'll maintain this Iowa advantage that we can take advantage of going forward. So the science assessment is out, or almost out, it's complete. Kind of our next steps are outreach like this to help describe what's in it, help people understand that, potentially launch into some new research and new collaborations to try and fill those gaps. Ultimately, hopefully we can provide information that can lead to more credible and cost-effective carbon programs going forward. But this one, we want to increase the application of a lot of these practices anyway. Even if all these carbon credit programs blew up and didn't exist, we still want to reduce nitrous oxide emissions. We still want to increase Iowa soil carbon. We still want improved water quality. And so we think these elements all provide value even without the credit market. The full report should be coming soon. This website, that's where it will be posted. There's a new extension website coming out focused on carbon that will be out soon. And there's a number of discussions that relate to this that are archived by the Bioeconomy Institute, conversations about carbon, and those will keep coming, and stay tuned to that. If you need further information on the report in general, either Lisa or myself, and Lisa said to put me first because she doesn't want to, she's kind of busy at the moment, or definitely the different chapter leads are a place to start as well. Rushed through a lot and I skipped half the report, but other questions? Yes.
Well, we know how the federal level stands. Biden and Vilsack are very much pro carbon sequestration, climate smart farming. The state level, on the other hand, I want to ask you about your reading on that, because they dismantled the Leopold Center that was working on these very things. It could continue to fill a lot of gaps in information. So is this all going to, is this work all going to be?
Could you repeat, please?
All right, don't say anything about, just say what's happening on the state level.
Yeah, the question is what's happening on the state level that's relevant to policy, and not really plugged into what's happening on the state level policy, what's happening next on this front. But as long as there's investments happening, and I think there's going to be interest. What form that takes, I don't know, but the policy side is definitely outside my purview and expertise.
Sorry, Jim, I'm going to ask a very similar question. So why do you have to wait for IEDA to release the report? Why do they care so much?
The question is, why do we have to wait to release the report? Because the initial structure of this is that our report would be in parallel with an IEDA report that I think is a bit more policy focused, and that report isn't ready to be released. And so it's not wanting us to be ahead of their process. And so we've done everything we can do, but we're waiting for the other side to complete that piece.
Who's writing that report?
I think IEDA itself is in the lead on that, I think. Yes.
So we've got Ashley, who's online, that has been patiently waiting to ask you a question. So Ashley, if you can go ahead and unmute and you can ask your question.
Okay, thanks, Laura. My question was, you mentioned spatial variability, but I just wanted to say that a study in Indiana that I was involved in, we found that the landscape position kind of swamped management effect on many things related to soil quality. And I believe carbon was one of them, as you can imagine. This was in the Morainal Hill area of Northeast Indiana. And I believe, it's a similar landform that it's in Iowa. So there's that. I wanted to mention, you mentioned spatial variability, but not really what are we going to do about it? And then measurement, the measurements that are kind of tried and true take many years to, maybe like 5 years at least, to measure a real change in soil carbon. And so I'm sure, folks like Dr. Castellano, who found something very counterintuitive in Iowa, that in a long-term study that I believe it was either corn soybean rotation or maybe just corn on corn, but had a better effect in terms of accumulating carbon than a perennial system. So I don't think we want to wait 5 years to determine whether or not a management effect is going to be beneficial. So I know that there are alternative ways of measuring carbon that maybe serve as a compass towards, are we accumulating carbon? Are we oxidizing? Are we going steady? So just some thoughts there I wanted to throw out there. I've just started a new role at Geosmin Agricultural Solutions, where I'm actually in this fight, working with farmers to put research out on their fields, because it's going to take research level experimentation to kind of establish where they're at initially, where they're going to be going. I just came from Ward Labs in Nebraska, where I, was the bearer of good news and bad news to farmers when it came to, are they accumulating carbon or not based on their management, and had a lot of disconcerting conversations with people, and there's not even any real money involved at this point. So I'm optimistic, but we really have to let people know on the front end how complicated it is, what we're getting into.
Those are all good comments. I don't disagree with any of that. We definitely have a number of challenges here. Other comments or questions?
So when you consider the soil plant systems and then the completely livestock-based systems, will the carbon credits apply to the same way to both of those systems? Or because, as he noted, he said for plant and soil, it may take about 5 years to realize, but for livestock system, I think it takes shorter. So is there a way they will compensate both of these systems equally, or it be unfair to one and fair to the other?
Yeah, the question is on differences between credits in the livestock sector versus the crop or agronomic sector. And our report focuses more on the crop side. That's kind of where the market activity is at present. On the voluntary side, the activity and the dollars available are kind of driven by the compliance side in terms of methane offsets at present. But I think that kind of laying out there's potential activity for other voluntary side credits to happen. But kind of related to what you're saying, to understand what's happening on the livestock side, you have to kind of think of the cropping side at the same time. And that complexity is kind of a challenge. We have to look at it kind of holistically. God, did you have a comment or question?
Yeah, so I wonder if you have any insights for how the contracts are being set up with the farmers, particularly, so right now they're being paid on an estimated value of the management practice with the verification coming later. Any sense of how that system will respond when the results are different than what was predicted by the management?
Restating the question is, how will these payments play out when measurements may be different than was originally projected at the farm? And it kind of raised by the prior caller as well, that what's actually measured may not be what was understood. And as we talked before, the challenges of measuring the change may be there, but we couldn't find it as well. And so exactly how that will play out in terms of agreements and payments, I don't know. I don't know if Brian, you're more plugged into that, or
yeah, the contracts I've seen, I'm on the farming side, is that that's not addressed. That's another one of those big questions that we don't know if we're going to be cut off from a contract or not. Yeah, it's not addressing the things I've seen as Corteva and Indigo.
But that may help, but so for sure, like a farmer gets a payment this year.
But I can take it away.
Okay.
But maybe cut off in the future.
Okay.
Yeah.
But that provides some insights.
Yeah.
It reduces the risk a little bit.
Yeah.
What you don't want is to have to owe money back.
Right. No. I mean, I haven't seen that in the contract. But Jim, just a quick comment is on the farmer survey. That's for sure. You go to any co-op, and people don't know what to do because a lot of people are saying, maybe I should wait. Maybe there'll be a better deal coming. I don't know. What am I gonna have to do? So it's a tremendous. I mean, from what I've seen in my neck of the woods in Franklin County, is exactly what you see in the survey. Is that the uncertainty? People are very interested. Obviously, if there's going to be some money involved, people are very interested, but people don't know what to do. They really don't know what to do right now. I think this is going to help a lot. Is the report is going to shed a lot of light on stuff.
And I kind of want to reiterate something I said earlier on. It's not really our objective here to advocate for or criticize any program or market, just trying to clarify what we know and don't know and how we can fill gaps and help people understand. But there's definitely a lot of questions, a lot of work to be done on measuring carbon, especially this sampling question and thinking about how it fits into the landscapes and how to fit all that into models to try and minimize how much we actually have to sample to confirm. There's a lot of things to sort out. Yeah. Hey, Dr. Cruz.
Yeah, did you have a question?
I think it just popped up like it did last time.
That's
So,
him, that's just him.
Rick, if you have a question, go ahead and unmute. Otherwise, we're not sure why your face is showing. It's good to see you. Okay, thanks.
I have one more question, Jim. You mentioned at the beginning, life cycle analysis, and I think related to pipelines. Is that something addressed in this that you guys looked at? Because in my neck of the woods, there's a lot of concern about the pipelines, and people are asking, well, this sounds like people say this sounds like a crazy thing to dig a pipeline through the farm to transport CO2. Is that something that will be in this that you guys looked at?
Question is about pipelines and life cycle analysis. Some of the science behind doing the pipelines in general and what kind of aquifer materials fit, that part is in the report. And the life cycle analysis is more on the understanding the process of looking at kind of a cradle to grave analysis of a system and some of the relative loads of carbon and greenhouse gases at different parts of a system, like turning biomass into energy, capturing the CO2, those kinds of things. But the pipelines per se, Summit Carbon, this line here, we don't do a specific analysis of that. It's more the general idea of how the different pieces fit together and relative impacts and the importance of life cycle analysis, understanding supply chain issues.
Ashley, did you have another comment or question? I see your hand is raised, but I don't know if that's from the first time.
No, I'm sorry. I'll put my hand down.
Is that it?
That's it.
Okay, well, thank you for your attention and let us know if you have comments on the report when we get it out. We'll be glad to get incorporated into another edition possibly later. So,
Thanks, Jim.
I don't know if he's messing with us, but I do see that Rick did raise his hand.
You got time for a quick question?
Yeah, for you, Rick, anything.
Oh, good. Or comment. We struggled in trying to identify things, for instance, tillage practices and others, their impact on carbon accumulation. And that's largely because the research has been done. The soils at which you started an experiment have a memory, a carbon memory based on what management practice was used previously. So for instance, Madiel Casey's work indicated by switching to no-till, you could accumulate 500 pounds of carbon per year. But had those soils been in something like prairie before he started, his results would have been completely different. So one of the weaknesses that we do have in trying to project what management is going to do is what legacy effect we have as we begin those experiments. The graph that you showed that Marshall contributed illustrates that. Changing practices change what the influence of other practices. So, okay, now I've said what I wanted to say.
all right, thanks, Rick.